Okay, now in this step, we are going to use the Z-score to actually identify which genes are upregulated or downregulated between, in subtype number 1 versus 2 and 4, 2 to 4. So what we will do is we will insert another column here, which is the Z-score difference. So which is very similar, which is basically your target group, okay, oh, which is basically your target group minus the Z-score from your, oh, because of this, minus your comparative group here. So then you can see that, okay, the Z-score difference between your subgroup 1 and also the 2 to 4 is actually about 0.189 Z-score here. So we just want to look at the difference, so that will give you some kind of magnitude, how much different it is. Okay, so we're going to copy this to here. Okay, again, we're going to paste this value here. Okay, now, so how are you going to identify the uh, the genes that are significantly up or down regulated? So you can use t-test alone. So this is statistically significant. Statistically speaking, there's nothing wrong if you use the t-test. If t is less than zero, I mean if p is less than 0.01 or 0.05, then you will categorize it as a significant difference. Now, you can also use just the Z-score difference alone. Okay, so that will give you the biological significance sort of. So if you say that if the Z-score difference of 2 consider significance, you can also use that as a cutoff. If you want to be a little bit more robust, you can combine the both. So that is what we normally use. Okay, so we will give the first criteria is that the Z difference must be, okay, more than, well, we have to try and error here. If we put more than or greater than 2, okay, see, then there's not many genes that is actually that significant. Okay, there's only a couple of those. So maybe it's a little bit too stringent in this point. So I'm going to reduce it maybe to greater than 1.5. Okay, so now this will be the genes that are significantly upregulated in your subtype 1. So again, if I filter it through the t-test, you will see that, okay, almost all of these are ridiculous p-value. They are extremely statistical significance in this case here. Okay, so you can still put it as less than or equals to 0.01, let's say. Okay, so now that you will have this is the genes that are upregulated. Okay, I will put it into a separate sheet. So indicate that as upregulated genes. Now, and similarly, so I will remain the t-test still p less than 0.01. I'm going to change this difference into less than or equals to minus 1.5. So, right, so if anything more than 1.5 is considered upregulated, anything less than minus 1.5 is considered downregulated. Okay, well, there's nothing here, is it? That is strange. Yeah, that's the highest is actually minus 1.3. So, yeah. So what is show you here is basically probably, well, each of the gene expression is actually quite varied across the sample. So we probably have to loosen the stringency a little bit more. So if we put it less than 1, let's say minus 1, so then, and then filter by the t-test, so you'll still be fine. So this will be considered downregulated. So I have to redo this with the upregulated genes so that they are on the same cutoff. Okay. Okay. So now you have a list of upregulated and the downregulated genes here. So I'm going to show you the whole process here. I'm going to insert this into the connectivity map because once you get a list like this, whether it is from the C-score or whether it is from supervised clustering or whatsoever, so the downstream process is the same. I'm going to show you how you insert it into the connectivity map, and then I will show you how you can actually interpret it. Okay, then after that I will then come back to show you how to do the supervised or the unsupervised clustering, because that one need a specialized software, so which I do not know where, I don't think you have it basically, and you need to probably install it in your laptop or something to do it. Okay, so now